let's do a 3 of a kind. That'll be the hardest one we've done yet. So what's the easiest thing to start with?
10.
There you go. All right. Okay. 13, choose 1. So now you have one kind. All right, now what? 4.
3.
I'd be happier if you said 4, choose 3. It'll also make it easier not to be led astray. Okay, but we're not done yet, right? Because now how many cards do you have in your hand? 3. How many do we need?
2.
2 more. Okay.
12.
See, you don't
12
care
choose
about the
one.
suit, right, anymore. So you're just, you only have, how many cards left? Is that 49 cards left, right?
Well, okay, so let's say you've already got 3 aces. If you got a 4th ace, you'd have 4 of a kind. So let's not define 4 of a kind or a full house as 3 of a kind, right? You tend to define your hand by the highest thing it is. So
So,
you can't choose from 49, but you can choose from
48?
48. How many cards shall we choose from the 48?
2.
Well, but if we choose 2, let's
One,
say...
choose one, and then you have 47, and choose one of them.
Well,
So you,
if we choose from 47, we can still get 2 kings, and then
oh,
we're
you get a
stuck with...
full house, right?
Yeah.
So, 44?
Yes, very good. You got it. And that way, you can't have a full house or of a kind. But that gives us the probability of getting exactly 3 of them.
Can you explain why it's 44 one more time?
Sure. Let's say the 3 of a kind come from the aces, right? So now we get rid of that. And then you got one more card that happens to be from the king, and you got this one, but you also have to get rid of these. Right? So that only leaves 44 cards left over. 4 times 11. So have you had your fill of poker? Yes? No? Maybe? We can do more, but at some point it gets a little bit tedious. At least I've gotten requests for other subject matter at this point. Yes?
I think you lost me on that second one. I didn't understand. I understand 13, choose 1
Here?
on the 3 of a kind, but I thought that was good. The next one was going to be 3 because 1 has been chosen already. I was confused why.
Here?
Yes,
Okay,
on the next
so
one.
what are you choosing here?
You're choosing one number out of 13,
You're choosing a kind.
a kind out of 13.
So when you choose a kind, you've got 4 cards, right? There are 4 cards of, say, aces. Yes?
Mm-hmm.
So out of those 4, how many do you want?
You want 3.
You want 3 because you want 3 of a kind, right?
Right.
Okay, but you still have to outlaw that last one. Because if you didn't, you might have 4 of a kind. Right?
Right, right.
That's why you only have 48 to choose from here. And you only pick one, and let's say this was a king, then you still have to outlaw the other kings, because otherwise you could get a full house, and that's why you multiply by 44, choose 1.
And that's because we don't want to count a full house as a 3 of a kind.
Right. Yeah. I mean, it depends on how you define it, but yeah. Other questions? Okay. This is about as tricky as we're going to get when it comes to counting. So the other approach to calculating probabilities is to literally use empirical data. So let's say you're renting out polishers. You have numbers of polishers rented ranging from 0 to 4 over a 40-day period with these numbers. So if there are 40 days and you rented 0 polishers out 4 of those days, what would be your estimate for the probability of renting out 0 polishers on any one day?
1 in 10.
1 in 10. And how'd you get that?
4 days had 0 polishers out of 40.
4
40
out of
about
40. Very good. And you do that systematically, which gives you 10%, 15%, and so on, of course adding up to 1. And this is a discrete probability distribution, which we're going to spend a lot of time on next week. But that's how you estimate probabilities using the relative frequency method. Okay.